Now, today we are looking at derived quantities and units. Now, what are derived quantities and units? Derived quantities and units are those obtained by simple combination of fundamental quantities and units. It can also be like they are the quantities that depend on fundamental quantities and units. Let's pick any of the fundamental quantity. Let's say mass and length. Okay, so if I combine mass and length, the result is going to be a derived quantity. Now, the combination can either be that of multiplication or division. All right, like if I multiply length times length, recall length is a fundamental quantity, right? If I multiply length by length, the result is going to be a derived quantity. That is simple combination we are talking about. It can either be division. I can multiply them like 3 times. Like if I still multiply length times length times length, it's going to give me a quantity, and that quantity is a derived quantity. Okay, so that is what derived quantity and unit is all about. It's just a simple combination of the fundamental quantity and unit. Whatever result you will have, that is your derived quantities. Now, we have a lot of examples of derived quantity and unit. That is, those quantities are obtained as a result of what? Combination of the fundamental quantities. Okay, now one of the example of a derived quantity, we have area, we have volume, we have density, we have velocity, we have acceleration, we have work done, we have momentum, we have force. Okay, they are plenty. Frequency is a derived quantity. We have a lot of them. Okay, now I'm going to show you how we combine, or what quantities are combined in order to give us this derived quantity and units that I made mention of. I will show you the quantities that are combined, that is, out of the fundamental quantities that we have. I will show you which of the quantities are combined in order to give us acceleration, in order to give us velocity, in order to give us density, and a lot of them. Okay,
from the example of the derived quantity, we have area as a derived quantity, area, right? And the symbol is capital letter A. We use capital letter A to represent area. Now, what are the fundamental quantities that were combined together in order to give us area as a derived quantity? Now, area, it is a combination of length. Okay, so area is length times breadth. Okay, we know that L is measured in meter and breadth is also measured in meter. All they are talking about what? Length. The derived unit for area is, if I multiply the unit of m times m, what am I going to have? M squared. So you see, this derived quantity, area, right, and the derived unit for area is what? Meter squared. Are we all together? Okay, now the next quantity is volume. Now, volume is a combination of what kind of fundamental quantity? Is a combination of length times breadth times height. Okay, length is measured in meter, is the same thing. breadth is also meter and my height is also meter. Are we all together? Length, breadth and height, they are talking about the same thing. The general name is length. Are we all together? So if I multiply meter times meter times meter, what am I going to have? Meter cube. Okay, so this derived quantity volume, the derived unit of volume is meter cube. Okay, so you see the simple combination here is multiplication. All right, now the next quantity, derived quantity, is density. Density, oh, the symbol for volume is capital letter V, so density. Okay, now we use rho to represent density. Okay, now density is mass over volume. This density, mass over volume, and we know that mass is what? A fundamental quantity, and volume is a derived quantity. But we have fundamental quantity that resulted to volume. So what we are going to have here is my mass, which is kg, divided by m cube. All right, so the fundamental unit for density is kilogram per meter cube. This is the fundamental unit for density. It can also be written like this: fundamental unit for density. Are we? The next quantity is velocity. Okay, velocity, we use small letter v to represent velocity. All right, now velocity is displacement. Displacement over time. Displacement over time. Now displacement is measured in meter. Okay, so we have the unit now is m over second, right? The fundamental unit of time is what? Second. Okay, so the unit of velocity is meter per second. Can either be like this or it can either be like this. Are we all together? Okay, so this is how the fundamental quantity are simply combined together. So every derived quantity we have, they are what? As a result of simple combination of our fundamental quantity. Okay, please stay back. The next thing is I'm going to show you how to analyze this physical quantity. How do we analyze these physical quantities that we have? Okay,